Okay, let's take a look at the next problem. The next problem is asking us to find the values of VA, VB, VC, and I1. If we look at our circuit, we have VA, VB, and VC. Then I1's right there. And we'll notice these are all nodal points, and the nodal points are going to be kind of an indication of what you are going to use for your method. And if you see, they give you a node, so V of G down here is equal to 0. So that's pretty useful for us. And if we have a ground, that kind of implies that we're going to go ahead and do the nodal analysis method. So let's kind of take a look at what this looks like. So if we know this is 0, then we know everything along this wire here is going to be 0 up until it hits an element. Okay, so then we see here we go through this 10-volt battery and we pick up 10 volts. And then here we are at this node with 10 volts. So off the bat, we know that V of A is equal to 10 volts. There we go. All right, but we still have VB and VC and I1 defined. So let's go ahead and take a look at the V of B, and let's assume that all of our currents are going to be exiting. So if I come here and I will draw all of these out, and we already have an I of 1 named, so I will call this one I of 2, I'll call this one I of 3, and then we know here that that's 4 milliamps, so we can just go and write 4 milliamps. Okay, so if we go and write I2 plus I3 plus 4 milliamps is equal to 0, it's just a KCL, then we can go in here and say that we can replace all of our currents with V over R, which will just be V of start minus V of end over R that we cross over. So if we go in here and do that, we'll see that I of 2 is going to be V of B minus V of A over 1 kiloohm. I of 3 is going to be V of B minus V of G over 2 kiloohms. Then we have 4 milliamps. And that'll be equal to 0. Okay, so let's go in here and just start simplifying down. We know V of G is 0. We know V of A is 10. And we can see in here that the only thing we don't know is VB. So let's go and kind of make this easier on ourselves, and we'll go ahead and multiply by 2 kiloohms to simplify all this down. So here we will get 2 V of B minus 10 plus V of B minus 0, then plus 4 milliamps times 2 kiloohms is equal to 0. So here we'll get 2 V of B minus 20 plus V of B, and then 4 milliamps. Remember, milliamps is equal to 10 to the negative third. Then kiloohms is equal to 10 to the third. So those two will cancel out. So it'll be here. I'll just write it out over here. So 4 times 10 to the negative third amps times 2 times 10 to the third ohms. That will give us 8 volts. So this will be plus 8, and this will be equal to 0. So if we combine like terms, we'll get 3v of b is equal to 12. Yeah, negative 20 plus 8 will give us negative 12. Moved over to the other side, so v of b will be equal to 4 volts. Okay, and then same deal with v of c. We'll go in here and just say we have all of our currents. Now we do know this 4 milliamps, so I'll put this there. That's v of b. V of c, we do know that the 4 milliamps is coming in. So if we draw that out, 4 milliamps coming in this way, I will call this one I4, and I'll call that one I5. So I'll have negative 4 milliamps plus I4 plus I5 is equal to 0. And then just as before, I'll go in here and replace my currents. So plus I4, we're going from V of C to V of A, and we're crossing over 4 kiloohms. And then I5, we're going from V of C to ground, and we're crossing over also 4 kiloohms. And we're equal to 0. Okay. Then like we said before, we know that's 0, we know that's 10. And if we go in here and multiply by 4 kiloohms, we will get negative 16. Then we will get V of C minus 10 plus V of C is equal to 0. We'll go and combine like terms. We'll get 2V of C is equal to 26. So therefore, V of C is going to be equal to 13 volts. All right. Now to find I of 1. So to find I of 1, let's go ahead and do one more nodal analysis. So we know that we're going to say I of 1 is coming in this way. Do this and then that. Call that one I of 2 and call this one I of 4, just to keep it consistent. It's just this one up here. Okay, so then if I do minus I1 plus I2 plus I4 is equal to 0. And I can come in here and I start dropping things in, so minus I1. So I2 is going to be V of A minus V of B over 1 kiloohm. And then I4 is going to be V of A minus V of C over 4 kiloohms is equal to 0. All right, and I know all the values for all the voltages. V of C we said was 13. V of A we said was 10. V of B we said was 4. And V of A was also 10. So if we come in here, we'll get negative 1 and plus 6 volts over 1 kiloohm plus negative 3 over 4 kiloohms is equal to 0. So therefore, we can say I of 1 is equal to 6 volts over 1 kiloohm plus negative 3 volts over 4 kiloohms. And let's do some quick math, find out what that is. .25 milliamps for I1. All right, so just nodal analysis over and over and over again.